In this chapter, we will be studying linear second-order differential equations of the form a times y double prime plus by prime plus cy equals f of t. Now, note that in this differential equation, all the constants or all the coefficients are constants. We have a is a constant here, b is a constant, and c is a constant. And in this section, we will look at the special case where f of t equals 0. When the right-hand side of a differential equation of this form is 0, we call that the homogeneous equation. So this right here is called the homogeneous equation. Now, the way we solve this is by an educated guess. So we're going to try to substitute y of t equals e to the power rt, where r is a constant. So we have that the function y is e to the power rt, then the derivative is r times e to the power rt by the chain rule, and then y double prime is r squared e to the power rt. So now take all of this and substitute it into this equation. So we get a times y double prime. So y double prime is that r squared e to the power rt, and then plus b and let me put in plus c here, equals 0. And now let's plug in y prime and y. So we have b times r e to the power rt, and then plus c times e to the power rt. Now note that all these terms have a factor of e to the power rt, so we can factor that out. And so if we factor that out, we get e to the power rt, and then we get a times r squared plus b times r plus c. Right? So we get ar squared plus br plus c, and that equals 0. And the exponential function can never be 0, so we could divide both sides by e to the power rt, and we're left with this equation here, ar squared plus br plus c equals 0. So that's what we see here. This equation here is called the auxiliary equation associated with the homogeneous equation 2. So this equation right here. Note that the function y of t equals e to the power rt is a solution to this differential equation if and only if r is a solution to this auxiliary equation. Now, this is a quadratic equation, and we can find its roots by applying the quadratic formula. and we get r1 equals negative b plus the square root of b squared minus 4ac over 2a, and r2 equals negative b minus the square root of b squared minus 4ac over 2a. The discriminant d, which is equal to b squared minus 4ac, tells us the following about the types of solutions. So if d is greater than 0, that means that we have two real solutions. If d is 0, then these two solutions collapse into one solution, right? We get plus square root of 0 is plus 0, and we get minus 0, so that's the same. And so we have one real solution, and that solution has multiplicity 2. And when d is less than 0, that means we have two complex solutions. Now, we will see what these first two types of solutions mean for the differential equation in this section, and then in the next section we'll look at what happens when we have complex solutions to our auxiliary equation.